Hey folks, Quill18 here, and welcome to another episode of our mostly civilized hex engine in Unity. Last episode, we set up the basic cube-based coordinates for our hexes and gained the ability to spawn a simple map. This episode, what we're going to do is we're going to colorify our tiles so that they're a little more interesting to look at. It's not going to be a real sort of terrain sort of like mapping, but it will at least initiate something that's more interesting to look at and will help us start to think about how we might want our terrain to work. The other thing we're going to do is we're going to implement cylindrical wrapping so that as your camera moves over here, say towards the right, the world will just keep looping over and over and over again. So we're going to try to look at those two things today. So let's start with the colors, because first of all, if there's no colors, you're not really going to be able to tell that the world is looping because it's just going to look all white, and that's not going to be very interesting. So let's do that. There's a couple of different ways you can do it. One thing you could do, so really, coloring the tiles is ultimately going to mean applying different material to them. Or suppose you could set the color of each individual material, but that doesn't make much sense. Later on, we're going to want to do a couple of different things. We're actually going to want to use slightly different hex prefabs, because we're going to want to use one prefab for flat tiles, and another prefab for hills, and another one for mountains, that sort of thing, right? But for now, we're just going to color things differently. So we could have an array, public material array of hex materials. Okay, we could do that. Well, I mean, we're probably going to do this, but what I'm going to say is what we could do at this point is then go and create a bunch of materials, right? Create material of a certain color, and we, apply it to the array here of size blah, blah, blah. Okay, and preload those in. Well, I guess I still could. I was just going to, randomly assign them colors in the script just for testing, but there's really no point in doing that. You're never going to use that for realsies. So I guess we'll go ahead and do the material. Okay, let's make a folder for materials. And in there, I'm actually going to create another subfolder specifically for terrain, because I think it makes sense to keep those organized together. So we're going to create a material. We're going to call this one grassland. We're going to have another one for, I guess I could just duplicate it at this point, plain. Duplicate you. We're going to have one for mountain. And just right now, we will make another one for water. There we go. So let's just color these. So grassland is going to be sort of a darker green. Mountains, I'm going to suggest, are going to be kind of grayish. A plain is going to be sort of a, yellowy sort of dry grass kind of thing. And water will make blue. I think that's a pretty good little basis. Something like that. There we go. Not too much. So then in the hex map, so we're going to say, here's a fun little trick. So let's say, regardless of what you have, let's say, if we did have some size, right, I could drag them in one at a time. That would be fine. But as a little trick for an array like this, lock the inspector. That way, no matter what, we still have the hex map selected there no matter what we click on. Then what you can do is you can click on grassland, shift click on water, drop it into the materials. Done. Just make sure you unlock this, otherwise you can get yourself real confused. So we have gone and assigned the 4 materials to the hex map. So it's got a list over there. And all we're going to do is when we instantiate our hex, we're going to go and give it a random material. So when we instantiate it, we're going to grab a copy, game object, hex, game object, and then we have to go ahead and cast it that way. So what we can do at that point is say get component in children, because the base game object won't actually have the renderer. So we're going to get that. We're going to find the mesh renderer in here. I will just keep a copy of it momentarily. MR is equal to this. Whoops. Now, MR has a material slot. So what we're just going to do is we're going to set that material slot to one of our hex materials as random. So hex material, it wants a number in here, so we're going to tell it random.range from 0 to the hex material .length. And we're using integers. Random.range uses this max -1. So it'll never return a number that's actually the length. It'll always do it -1, which is correct for an array index. So we're just going to set the mesh renderer's material to one of these at random. So now, if we hit play, boop, There we go. We get a little colored world over here. And isn't that lovely? And now we could actually get rid of the shaded wireframe mode over here. Hey, you know what? I'm going to leave the wired frame. Make it a little clearer still for now what's going on. But we've got a nice little display over here. Now, some very interesting things can start to happen now if we go into the game mode and look at the stats. We can actually see that things are being batched over here. There are actually surprisingly few draw calls being happened, even though... So each batch is one draw call sent to the set to your video card. Even though there are currently 100 different tiles, we don't have 100 different batches, because Unity is smart enough to do dynamic batching. It realizes that a lot of these objects are using the same material, so it groups all the objects that use the same material together and sends them as one draw call automatically for you using dynamic batching. And this will mostly work most of the time and saves you a lot of draw calls, which is really, really good. In fact, in your actual game, you would be doing fewer draw calls than this. These batches include things like some of the UI stuff and different menus and things like that happening within the editor. So your actual in-game draw calls are probably in practice a little lower, assuming I'm correctly remembering a couple of things. Maybe things have been tuned since then. There's a few other things you could do. Notice we didn't have to use shared material to get that done. Just mr.material is perfectly fine. You can, if you want, when you're done all this, you could actually go one step a little harder here by enabling, maybe you don't know, that one of the great ways to optimize drawing and all kinds of things in Unity is by setting the static flag on an object. When an object is marked static, that tells Unity this object is never going to move at all. It actually also will not change materials. I don't think that's actually true. But it will never move. This allows optimization for the physics system, but it also allows optimization for the rendering engine. Now, there is, on a game object, the isStatic flag. And technically you can set this to true. This does nothing when your game is actually running, because static batching and things like that do not get affected by this flag getting set true or false at runtime. It's a little deceptive. It's handy because you can do things that run in the editor, and you can set static flags at that point before your program compiles or something like that. But in practice, this really does nothing for you, unfortunately. There is a way to get static batching at runtime, though, and that's to use the static batching utility and say, hey, can you combine some objects? You have to pass it to root object. In this case, we're going to pass it ourselves, right? This is our hex map. All of the hex tiles are children of the hex map. We could go and do this combine. This is actually kind of interesting. If we hit play, boom. We should still have the stats up. Batches, notice the batches are a little bit less. Not crazy less, but they are there. Although that may have also to do with just like the differences in how many different materials and how these are lined up. Okay, we still have all the children. Notice they don't have the static checkbox marked in here, but these are static. And the good way to identify this is if I try to take this object and move it. Notice it's not changing. If you look at the transform, as I drag this around, the transform coordinates are changing, but where the object is being rendered is not. That's because this object is completely static. It cannot be moved. It can be deleted. I can take this and I can delete it. That's fine. And I believe, let's find out together. I believe I can still change the material. So we're going to change this one from mountain to a plane. So the material can be changed. An object can still be deleted, but it can no longer be moved. And for some hex systems and some terrain engines, that might be good. You're like, well, why would the terrain ever move? Well, that's how we're going to do our wraparound, right? If we want the world to wrap cylindrically, what's going to happen is when the camera moves over to the side, the stuff that's off the screen, we're going to move it. We're going to teleport it over to the right over here so that it's all one seamless world as you keep panning towards the east, for example. So we cannot actually use static batching for our particular purposes. But depending on what you're trying to do, this might be like the hotness, the greatness. So we're gonna leave that off. But now, okay, so now we've colorified things so things look a little bit more interesting. We're gonna make the world a little bit bigger. I'm gonna go something like int map dimensions equals, let's make it 20, just a little bit bigger. There we go, something like that. I mean, I suppose I could actually go something You know what? I might want to. Int map height is equal to 20. Int map width is equal to 40. You know what? That sounds reasonable. So number of rows is that. Number of columns is this. So now if we hit play, we're going to generate 400 tiles. So there's no static batching optimization, but there's still only 19 batches being generated here. So there we go. So now this is going to be our world. Cool. Excellent. Wonderful. So we need to make it so that when the camera moves, the objects move along with it. So let's go and take a look at that. So the position of the hex is currently determined by this, h.position. So there's two things that need to happen when the camera moves so for the tiles to update. First of all, we need some sort of update function that runs every frame. It doesn't literally have to run every frame. You could have a trigger only on frames where the camera moved. For our first pass, we'll have it run every frame. That's fine. Later on, you can sort of tune the behavior a little to only run when the camera has actually moved or not. But we're gonna have some sort of update routine, all right? Could be in here. I won't. I'm going to make a slight different tweak. That's one thing. But the other thing is we need some sort of variant of position that sets the object in the right place based on where the camera is. And that is going to be another job for Hex to handle. So it's got this position function over here, but we're going to want another variant of it. And this thing's variant is going to be called something like position from camera. Okay? So let's make a public, it's also going to return a vector 3, position from camera. And what it's going to want is, it's going to need to be told where the camera is. Camera position. And it needs to know the width of the map. And the float height of the map. Which I just realized might be a little confusing because map width and map height is not literally the map width and the map height. This instead is, this is more like num rows and num columns. And the reason that is different is because the number of the actual height of the map is going to be equal to number of rows multiplied by the height of a hex, which happens to be 1. But the actual width of the map is going to be the number of columns multiplied by the width of a hex, which is not 1. It's going to be something else. So yeah, we're gonna rename this to over here to num rows and num columns, which we're going to use here to calculate map height, which is going to be, I guess we'll make a little public float hex height, which is going to be, we need to move the radius out to something. Well, we'll keep having it just hard-coded in here for now. But the height, return that. So then we can just use hex height over here. And then we'll do another one. Public float. It may not even need to be public, but what the hell, right? This could also be a good situation for a property or something like that. This is going to return the width multiplier multiplied by hex height. Like that. So we can get rid of this and that. Like that. So then the map height is actually going to be num columns multiplied by hex height. Hi, sorry for the weird cut. I'm interrupting me from the past here because me from the past is about to make a tiny mistake and then get really confused about it later on and everything's going to be haywire. So I've decided to roll back this video. Hopefully I've rolled it back correctly. What me from the past was about to do is to figure out the map height and map width. I was going to multiply the number of rows and number of columns by hex height and hex width. This is not correct. Instead, we need to multiply it by that vertical spacing and horizontal spacing. And we figured that out before when we were doing the position over here, right? We were figuring out the hex height and width, and then figuring out how much space, how much of a vertical and horizontal offset each hex is supposed to be. Turns out with the width, it's exactly the same. Hex width is the same as the horizontal spacing, not so much for the vertical spacing. So just like we just made the two little easy peasy little helpers for hex height and width, I made the same thing for vertical and horizontal spacing, just updated position to use that, and then we're going to figure this part out over here. So that's groovy. That's excellent. That's exactly what we want to do. Okay, now comes still some slightly, it's not hard math, but it's like we got to keep some things in our head and make sure we're correct. What we can do is we can figure out something like, say, map. We want to find, okay, we need to figure out how far off from the camera's position we are in terms of map width totals, okay? Just to start off with. We're going to do height as well because we're going to, as an example, we'll do vertical wrapping, but horizontal wrapping is the thing we care about right now. In fact, you know what? I'll even comment out the width. The width. Yes, width is how you pronounce height. Width and width. All right, we're going to comment out the height because we're just going to work with the width aspect over here. So we want to figure out how many widths from camera, as a for example over here. And that is we're going to figure out our current position. So let's do vector 3 position is equal to position. So our position dot x minus the camera position dot x, and then we're going to take this whole thing and divide it by the map width, okay? So ideally what we want is we want how many widths from camera. We want how many widths from camera to be between negative 0.5 to 0.5. That's our goal. We never want to be more than half the map width away from the camera. If we're at something like 0.6, that means we're too far to the right, and what we should do is loop around to the left to be in the right position and wait for there. At least the way we're doing it. I do want to point out there's many, many ways to do this kind of things. We could use some sort of collider hitbox that detects when things leave the camera's sort of like range that way and then moves things. I think this will work perfectly fine, but we might find out other ways to optimize it later on. But that's the sort of idea that we're looking for here. But then we got to offset things. So first of all, like we don't have to proceed any further unless, so if, how many map widths from camera, or if mathf dot absolute, just as a whatever, just, it might save us some steps. If it's less than or equal to 0.5f, then like, we're good. And we could just maybe like return just the regular position, for example, you know? Maybe it'll save us some math. Maybe this is unnecessary, but that's the sort of idea we want to do. So let's assume we're going to do that. Otherwise, what we have to do, well, yeah, we really don't have to get rid of this, is we have to fix our situation. Because what we have to do is we have to move ourselves right or left by map width, depending on how far off we are. So what we're going to do is we're going to get an integer at this point, which is how many widths to fix. And what this is going to do, what this is going to be is our how many widths from camera cast to an integer. Oops. So this is going to get the whole part of the float is what that's going to be. So let's say, you know, the camera sort of looped a couple of times. So now we're 2.2 units away. How many widths to fix is going to be equal to 2. Okay. So that would mean, in this case, this would mean we are 2 full map widths to the right of where we should be. Now, this is not entirely what we're looking for, though, because if we're at 0.6, we sort of need to fix that as well. So what I think we need to do is we need to add like half a unit. In the correct direction. Right? So let's come up with some examples. If we are at 0.6, then we want to be at negative 0.4. If we are at 2.2, then we want to be at 0.8 or 0.2. 0.2. Yes. So 2.6 would become negative 0.4 is the correct place for it to be. And also, if we're something like negative 0.6, we actually want to become positive 0.4. Like, we never want to be more than 0.5 away in either direction, positive or negative. So what we want to do is if we were to add a half a unit to this, I think it would fix it, because if we were at something like, if we are at 2.8, then we want to be at 0.3, 0.2? 0.3. Yeah, because at 0.8, we're 0.3 units too far away, right? If we were at, so this would be a good example. Oh, at negative, that's what we want to do. So if we're at 0.8, we want to be at negative 3. I think I done goofed here. Negative 2. Negative 2. Yeah, there we go. That's right. So if we take our number and add a half and then turn it into an int, that is correct. Although we'll have to add the int with the right sign, or the half with the right sign, right? Because how many widths from camera? If how many widths from camera is greater than 0, then we want to add 0.5. Else, we want to, at this point, remove 0.5. And then we can now turn this into an int, so it'll be positive or negative. Do we want to invert? Yeah, because if we're at 2.8, so this will become 3.3 positive. How many ints to fix? That's fine, because then what we want to do is we want to take our position dot x, and we want to subtract the how many widths to fix. So times the map width. There we go. I think this is vaguely right. Now, the thing is, we can do this check over here, but here's something to remember, right? If we were at this point, if we were at, say, 0.4, 0.4 is a good spot. It's perfectly acceptable, happy place to be. If we're at 0.4 and we added 0.5, that would be 0.9. When we int it, it would round to 0, which would mean we'd making no change whatsoever here. Same thing if we were already at negative 0.4, then we would be becoming negative 0.9, which should round to 0. I hope that's right. Yeah, like, I'm not crazy, right? If we, does this run at all? Right, you're going to complain because we're not returning a value. Well, I guess we're going to find out if this works or not. I'm pretty sure I'm right. I don't know, we'll find out. Let's return this. So my thing is, we don't necessarily need to check for the error case. We're just hoping to save some space. Oh, these two, let me comment these out for now. That was from our previous little go that went the wrong way here because of some confusion. Let's hit play. Where's my camera? Camera's here. Oh, yeah, we don't update it. Still, okay, you know what, though, still, that looks about right. See, our camera is here, and it looks like our camera is now centered left and right. That's exactly what we're looking for. Everything that was more than a half a map width away to the right has now been looped over to the left. That's very good. If I move the camera way over here and we hit play, the map should still be centered around here, and it is! Aha! Excellent. Okay. Very, very good. I was afraid I was going to do something like crazy over here. Anyway, so my point is, if we leave this out, all we're doing is saving a tiny little bit of math over here. And meanwhile, we're doing a little bit of extra comparison. I'm not convinced that we're actually saving any time by doing this check first. So we could just do this, and it's fine. You know, sort of like premature optimization, root of all evil, etc., etc. It was mostly a way to present like some of the logic going through here. So the idea with the wrapping east-west, north-south being allowed or not is because normally you wouldn't want to wrap north to south in one of these 4x maps because it doesn't make any sense. Remember, if let's say you're scrolling upwards on your map, right? You're moving upwards towards the North Pole. Then you pass the North Pole, even though you're going upwards still, what you're really doing at that point is starting to move south, right? Imagine you're starting at, I don't know, Moscow, and you're scrolling northwards, and you pass by other parts of Russia because I'm super good at geography until you hit the North Pole. And then you keep going upwards. Well, now what you're doing is you're entering northern Canada. Then you're going south into middle Canada, southern Canada, northern US. You keep going and eventually hit Mexico. Even though you're heading upwards on the map. Actually, I drew some pictures last time. Even though you're heading upwards on the map, what you're really working with at this point is a globe, right? So what you're doing is you're heading upwards, but now you're coming down on the other side, having crossed through the North Pole. What you think about more intuitively from a gameplay point of view is you're thinking more like this. You're thinking like a cylinder where you've got a map, right? This is the northern edge of the map. This is the southern edge of the map. And you'd think sort of when you hit the northern edge of the map, it teleports you to the bottom. So a cylinder this way, with like the seam here. So this is the southern edge of the map. So you're sort of teleporting to the southern seam of the map. Intuitively, that's the way you would sort of expect it to work in a game, okay? If the map is supposed to loop, you hit the northern edge, you teleport to the southern edge. But that's not actually how it works in a real Earth, which is why most 4X games, don't have north-south wrapping, because the wrapping, the way we would do it, right, which is treating it like a cylinder, feels intuitive but isn't realistic. Whereas going to the east and west totally does. You sort of expect if you keep heading this way, you'll pop up over here and keep going, and that is totally legitimate. Because what we're doing is we're treating it like a cylinder like this. So you're going around the cylinder over and over and over again. But reasonably, I mean, think about this. You can't have something that's both a cylinder this way and a cylinder this way. That shape doesn't really make much sense. I mean, you can do it. Anyway, no, that's why most games don't have the north-south looping. But there's no reason we can't offer it a feature, right? So what we can do here is use this Boolean and say something like, if allow wrapping east-west, then we do this. And then we can have, let's indent this. And then we can duplicate this entire code block over here and say, okay, and if you allow wrapping north-south, let's make sure to get the map height in here now. Then what we do is we just change these reference. How many heights from camera? We're doing position Z, camera position Z by map height, like that. How many heights, how many heights, how many heights, how many heights to fix? Here as well, we're doing position Z, how many heights to fix based on map height, boom, and like that. So you can just, by flipping these two Booleans on and off, you can determine whether you're allowed to wrap in both directions. Now, maybe this isn't the sort of thing that belongs in Hex. Maybe it belongs in Hex map, some correction ability like that. That's entirely possible. How are these things going to be set? We could figure that out. Maybe these are properties that belong in Hex map, and then inside of your Hex, you go and refer back to it or something like that. You could pass it as Booleans. Boolean, wrap east, west, etc., etc. Like there's, you can figure out different ways to pass those parameters. But now, if I were to, well, let's come back to this in a second. Let's come back to this in a second because we'll be able to show a live example. Because right now, it just happens once on creation, and then if I move the camera around, nothing else is happening. So let's make it move. Let's make it update when the camera moves. Okay. Couple of different ways to do it. Definitely. I think if we were to do it right, I think the right answer would be you should only redo the position of the hexes when the camera actually moves, as opposed to every frame. So let's put in a script on the camera itself. Well, you can either do it on the camera itself, or you can do it on a hex map, I suppose. You could go either way to update the tiles. Yeah, there's like a bunch of different versions. You know what I'm going to do? Here's what I'm going to do. I'm going to make a new script. C# script. And I'm going to call this hex component. This is going to be a mono behavior. This is going to be a component. I guess I could have called it hex behavior. But, I mean, it's a component on a game object, okay? It's not going to have a start or an update. It's going to, it's going to be really lightweight. All it's going to have is a public void update position, like this, okay? And it's going to have a reference, public hex. This is a component that's going to get added to our prefab. So we have our little prefab over here, right? Hex prefab. We're going to drop it on that. Then what's going to happen is when we instantiate our object right over here, our hex game object, we're going to say hex game object dot get component hex component, and we're just going to tell you, by the way, your hex is this. So now the game object knows what its data is. That's going to be fine, no problem there. And then what we're going to do is in this update position, it's going to be very simple. It's going to set, when this gets called, it's going to go this.transform.position is equal to the hex hex dot whoops cancel dot position from camera camera dot main dot transform dot position for 1. And then it needs to know the num rows. Oh yeah, so I guess let's also have it know public hex map, because then it can say something like hex map dot num. Is it columns or rows first? Rows. And then hex map dot num columns, like that. So again, we'll have to make sure when it gets created. There you go. So we do 2 of these little things. We don't, we could optimize it better, but hardly makes a difference. So there we go. So we're going to set the hex and the hex map of this hex component so it knows what's what. So when this function gets called, the component will move itself based on that. So the hex itself doesn't change. Nothing weird happens to the hex itself. The hex has a tool to help us calculate the correct position based on where the camera is, but that's it. So then our camera is going to have something like camera move handler. I mean, really, the camera's going to have probably some bunch of code that's in there to handle, like clicking and dragging it. I don't know. Camera motion handler, camera motion, camera mover, I don't know, something. So what we're going to do is we're going to take this script, throw it on there. So it's going to have a few things. It's going to have a few things in here. It's going to have like to do code to click and drag camera, WASD, zoom in and out. Maybe it'll have some sort of thing like a public void pan to hex. So it's going to like accept a hex. And it's going to like to move camera to hex. That sort of thing. It can have a variety of this kind of stuff. But one of the things it's going to do is it's going to remember vector3 vector3 old position equal this.transform.position. And then it's going to have, at the end of all this, it's going to have some sort of function here that says check if camera moved. I mean, we could set a flag. There's lots of things we could do. But what I'm going to do is I'm going to have a little helper function over here that's just going to be void check if camera moved. It's going to be very simple. If old position not equal this.transform.position, then something moved the camera. We don't know what, but something moved the camera, which is fine. What we're going to do is we're going to note the updated position. And then, and this is not going to be the fastest, but there's lots of ways we can update this later, although this is going to be fine. What we're going to do at this point is we're going to find all the hex components that are in play. This can be cached. There's all sorts of things that could be done, but we're going to cache, we're going to grab all the hex components that are in play at this point. So hex component array, hexes, is equal to game object dot find objects of type. We're going to get all the hex components that exist in Unity. To do. Probably hex map will have a dictionary of all these later. So we can read from this dictionary instead of using the game object.find objects of type, because this is not literally the fastest, especially if you just cache it. But for now, we're going to be fine. So then we're just going to say for each hex component, hex in hexes, we're just going to call hex.updatePosition. So if the camera has moved for any reason, whether it responded to this, whether it panned to a hex, whether, whatever triggered a camera move, or if we're in the Unity editor and we move the camera around using the Unity transform tools, this will trigger. And then we'll update all the hex positions at that time. So if we hit play, and then we take the main camera, if I start moving it around, Now notice, moving up and down does nothing right now because we do not, by default, allow the north-south wrapping. But left and right is clearly working. There's, there we go. There's a nice sequence right over here of 4 yellow tiles, right? Now I'm going to move to the right. We should see the 4 yellow tiles show up right over here. There they are, the 4 tiles. So we've got 3 and the 1 left over. If I move over, there's the 4th right there. Perfect, perfect looping. And then, if we decide that we want to be able to wrap north-south, say we set a true here. Again, we'll figure out some way to signal this. Again, this might be something that belongs to hex map later on. There could be all sorts of things. I mean, you could have your option menu to set this. If we find our camera over here and we move north and south, now we are wrapping in every direction. But again, north-south wrapping doesn't really make much sense. But if you want to do north-south wrapping, you can totally turn that on and do it. All right, that's great. I should throw some comments in here probably. Although these variables are pretty verbose here. What I should put a cut in this video. I think we're in pretty good shape. Was there anything else I was supposed to do originally before I confused myself with redoing this part of the recording? I don't know. We're kind of okay. How's the performance at this point? That'd be an interesting question to ask. So let's do this. We're going to go into, I may have already done this part. Project settings, quality. I've turned off the VSync, so I'll get an accurate count of frame rate. Accurate-ish, because there's some extra stuff that has to be rendered. We're going at 1200 FPS. And as I move the camera around, it does dip down to about 400 as it's doing the math to recalculate tile positions. But that's not too shabby. And again, that's with everything being individual game objects. Adding more texture details and things like this to these hexes will have very little impact on the performance whatsoever. It's mostly going to be a question of probably CPU overhead. Running animations and things like that will definitely add a bit more detail, and so on and so forth. If there starts to be more lighting, although all these tiles are lit. I mean, we've got a directional light in here that if I move it around, I mean, you can see the shine being altered there. And that may or may not be something that actually makes sense. Maybe no light, but instead some sort of custom shader would actually do this better. There might be shader stuff later on for blending. There might be vertex coloring. Like that might add a little bit of overhead. But I think from a rendering point of view, it's going to be fine. Again, batches, only 19 total batches. Things are being batched together very, very, very well. This was with 400 tiles in play. We could go a lot bigger, just as a for instance. Let's go and make our map 60 tiles high by 120 tiles wide. This will be a little slower, and of course I do have a pretty good system. Well, we're still running at 1200 FPS right now with no motion. The performance will tank a little bit more as it pans here, because it does have to check every single tile to see if something's got to be updated. So again, there's probably plenty of room for optimizing this. First of all, this lookup to do. Maybe there's a better way to call what hexes get updated, so that we don't have to call this as often. I mean, update position doesn't do much, right? At all. It just calls hex position from camera. But maybe, there's a way to confirm whether or not there was a change. This code is, are there any math optimizations we can find space for in here? I'm not convinced there's much. I think the big thing will be if there's a way for us to more easily call which one of these get run. And one thing we might do is we could attach some sort of like collider or trigger to the camera. So as the camera moves and things move in and out of the trigger, then maybe that'll be a way to hint as to which ones of them should be updated, because anything within the trigger wouldn't have to be updated because it's clearly already within the view. That being said, that might actually just add more overhead and actually hurt performance. So you'd have to test. You'd have to test and do some benchmarking to compare before and after if there's space. I'm sure people out there, there's some people out there who are better at a couple of things and can see different things, because not everyone always sees the same stuff, especially when one person is trying to commentate at the same time. There's probably some, a little tweak here and there, and maybe someone will figure it out. The code will be linked down below. Of course, it'll be over on GitHub, so I look forward to the feedback. There will be a gap between this video and the next one, because I'm going to be out of the country for a couple of weeks. When I come back, I do plan on recording a handful of these episodes. That we'll end up with just as many, but there will be a bit of delay between this episode and the next one. But I mean, I think we've already done a fair number of stuff, and actually I've answered quite a few questions. Oh yeah, this is huge. That people often have of all this. I guess one of the things you could do is, if you had an idea as to the maximum zoom or the most zoomed out a camera can be, and how many tiles could fit on the screen, which you could calculate. What you could do, you remember how we had our little check-in here of, doing the absolute? Well, it might be entirely possible for you to bail really early. Like if how many widths from camera is, if the absolute value of how many widths from camera is less than like 0.1, you might be able to bail early and do slightly less math. But this math is pretty minimal and pretty damn quick. I suspect that a lot of speed actually comes from, what happens if we just cache the hexes? What if we do something as simple as that, right? Let's say we move this out to here, and then we say something like, if hexes is equal to null, then we assign the hexes here. So we only ever going to do this one time, because the number of hexes in existence currently doesn't change, and honestly probably won't in most things. If we change that and therefore cut out the lookup, I'm curious as to, that's interesting, that the render times have changed a little bit. Probably, it's probably based on how many things are going there. Okay, so 1200 FPS. If I cycle around here, it's still dropping to about the same. So I would suggest that this is not very slow at all. But I bet you if we can limit how much looping is going on here early, then that could do it. But the thing is, doing the distance comparison for how many widths, just lets us avoid one comparison here, but we're already doing comparison. It avoids this plus here, but I mean, you're doing mathf.absolute. There's a couple of steps to that operation. So really, we save this conversion from a float to an integer, I guess, and this multiplication and then assignment there. It's really very little. I don't know. Anyway, that's for next time. Thanks for watching. See you then. Thank you to all our April Patreon supporters and these Mic Check supporters. We've got Harry Hendel. We've got Yukofin, Snoopy TRB, Tiburon, Pavel Zdanov, Drazion, Gavin Power, Michael McClintock, Aaron Toibson, Greg Mortel, The Not-So-Evil Engineer, Julien Auger-Lafont, Marisfield Vold, Speedy Savant, Steven Stagger, Valiant Cake Fiend, Jason Yanity, Steven Bonnerman, Kale the Quick, and Neil Blakey Milner, and everyone who's watched, shared, favorited, and subscribed to these videos. Thank you so, so much.